Okay, so let's first turn that 1 over 3 theta. So 1 over 3 theta equal to u. Okay, so we get down a third of the theta is equal to du. So you can replace the theta with 3 du. Okay, so we're going to get sine squared u. The theta is going to be 3 times du, so 3 times du. Now, u, when theta is 0, so when theta is 0, u is 0 also. But when theta is 2 pi, u is going to be, right, u is going to be 2 pi over 3. So let me put that there, 2 pi over 3. Okay, so to get the antiderivative of this, we have to use the cosine double angle formula. So cosine 2x, we know is this, 1 minus 2 sine squared x. So if you isolate that, okay, you get cosine of 2x minus 1. So if you isolate sine squared x, you get a 1 minus, okay, so the negative 1 turns into positive 1. The positive cosine 2x turns into minus cosine of 2x all over 2. So you have to replace with this. Okay, now we can find the derivative. Let me just pull out the half as a 3 over 2 at the front. Okay, so 3 over 2 times by antiderivative of 1 is x. That's going to be minus sine of 2x with half in front. Oops, sorry. I think I accidentally converted u into x in the middle of the equation. Okay, and then I'm going to plug in 2 pi over 3 and 0 in there. Okay, so if you plug in 2 pi over 3, you get 2 pi over 3 minus half. Okay, so that's sine, we get 2 times 2 pi over 3, that's 4 pi over 3. Okay, plug in 0, you're going to get 0 for both. Okay, so hopefully you know your special angles. This is 2 pi over 3. So that's the equivalent to actually a minus sine, because it's in the third quadrant. 4 pi over 3 is pi plus pi over 3. So it's minus pi over 3. It's a negative value for sine. Okay, so now we have, if you multiply that in, you're going to get pi 3 over 2 times by, that will give you 3 over 4, but there's 2 negative here, so it becomes positive. And sine pi over 3, that's sine of 60 degrees, that's root 3 over 2. So you get 3 root 3 all over 8.